Mr. Josh.
Paul, how you doing, sir?
Doing pretty good. Can you hear me okay?
Yeah, I can hear you great. Am I coming through all right myself?
Yeah.
Good.
Hey, I'm gonna need a favor from you if you don't mind.
Yeah, what's up?
Well, with your help, I just passed the CISSP yesterday.
Oh, Paul, no way. That's so awesome.
Thank you, man. Thank you.
Paul, congratulations. Seriously,
Thank you,
man. You have been showing up. You have been studying, working your tail off. You so earned that pass. Good job, man.
Thank you, sir. Thank you. Hey, man, and genuinely from my heart as well, man. I thank you, man, because you've been doing an awesome job as being the host and the presenter of this class. And I think you're already there, but I think you've definitely be going more places. You're professional. You give a good insight into class, and you come from different angles, which I like. Because this exam, I mean, I'm going to keep repeating it. I'm not someone who came in off the street and is taking this exam. I've years of experience in networking.
Yeah.
And this exam, for lack of a better word, kicked my ass, basically.
Yeah.
I mean, this is my third time taking it.
You got it, man. Third time. I forgot about that. Man, you got it. Well, Paul, first of all, thank you for those compliments. That's incredibly kind of you. I'm so excited. I mean, you're the one that's actually putting in the work at studying. That is just so cool. I'm not going to ask you any questions because I know everyone's going to have questions for you. But okay. I'll just tell you, I'm not pulling your leg or just telling you something to make you feel good. I think it was after one of the sessions last week, I was just wrapping up and cleaning up, and I was thinking to myself, man, I'm going to be a little bit bummed when Paul passes because I'm not going to get his questions anymore. So.
Yeah. No, I get it. I'm still going to show up on the calls, to be honest.
Yeah. Well, like you said, you're going to keep testing, keeping this stuff fresh. Yeah.
Exactly. Not only that, whatever I can lend to the community that's going for the test, because I know how hard this exam is.
Yeah. Paul, would you be interested in a mentorship program? There's another member you maybe have been in sessions with her, Marion. She goes by MB, but okay. She has been, she's asked about starting some sort of a mentorship program between people who have passed and kind of helping people who have their test dates scheduled and who are kind of showing promise.
Yeah, I'd be interested in that, definitely.
Okay, awesome, man. Yeah, I'll keep you on my list. But oh man, I'm so excited to hear your story. I'm gonna be patient.
Okay,
yeah.
No problem, man. And I'm not pulling your leg either. I mean, I'm not that kind of guy. I mean, I know I joke around, but I'm kind of a straight shooter, and you're doing an awesome job, man. I know everyone who's attended these sessions. Trust me, if you weren't, I'll be looking for another study group. I'm just, know what I
mean? Glad I got you in mind. Really grateful for that.
Yeah.
Awesome. Yeah. Well, hey, Adam, good to have you here. Marcia, I don't know that you and I have met before. Welcome to the study group.
Thank you. This is my first session, so I just started to join the study group, but I've been studying for the CISSP for a while.
Yeah.
But now I really want to dig in and really start putting some emphasis on it. So
absolutely.
Looking forward to this class. Thank you.
Absolutely. Oh, we're so glad to have you here. We'll give it a few more minutes. We usually have people join in a little bit late here. Cheryl, hi. Marcia, I'm wondering would you mind sharing with me a little bit of your background of where you're working, if you're working in the profession right now?
Yep. So right now I'm in cybersecurity. I've actually been in IT for several years, probably since the mid-90s. So I have some background in server administration with Windows, Linux, Unix, VMware.
Excellent.
And then when I came over to Disney, I was working on a contract and they had me work on vulnerability management. And then from there, that kind of led into cybersecurity, which I'm in right now.
Yeah.
And I'm doing user access management. So I'm looking at the application, OS, and database layers, making sure that, everyone is taking care of doing their user audits. So we're staying on task. So it's Disney is a big environment. So I'm working for one segment, which is Disney experiences, but I work with several other teams as well.
Okay. Well, you get your hands in a lot of different technologies and areas of business. That's neat.
Yeah, definitely.
Well, that's wonderful. One thing that we've noticed in the group is that people have usually a strength in a handful of domains in their background. My background is a little bit similar to you. You have more experience than I do, especially on like you mentioned, the identity piece of things. But like software is a weakness for me. And it's so nice when we get members of the community that can kind of jump in and help us out with things. So Ravanan is wonderful at that. Paul is, and Cheryl is as well. She's jumped in a lot. Cliff has a lot of experience in the healthcare industry, doing all sorts of stuff for server administration. But so really glad to have you here. Thanks for trusting us with your time and joining us.
All right. Well, thank you. This will be great. Looking forward to it.
Excellent. Cliff, good to see you. Rebecca, boy, if we have met, you'll have to forgive me because I have forgotten, but welcome to group. Glad to have you here.
Glad to be here.
Cliff, my friend. Excellent. Okay. Well, so I've met just about all of you now, but my name is Josh. I'll be your instructor for the evening. I'm not really an instructor. I am CISSP certified. I have my master's degree in cybersecurity and information assurance. I do work in the industry as a compliance and risk analyst, and I teach as well part-time. But I mentioned this last week. I love this group so much that I'm leaving my university teaching job just because I would love to spend the time with you guys more and more. You're demonstrating so much. I mean, Paul I'm going to ask some questions here, but he's been a member of this group for, well, as long as I have, pretty much. And he's been working his tail off, showing up, asking the best questions, and he just passed. So we're here we have him here on the call tonight.
Wait, Paul passed?
Yeah, Paul passed.
Oh, awesome, dude.
Yes, sir. Thank you,
awesome.
man. Thank you.
Yeah.
Much appreciated. Thank you, guys.
Seriously. So deserved. Anyone that has been on these sessions more than a couple of times has seen Paul show up and work and study. And, Paul, I hope I'm not making you feel bad about this. I just want to make you feel proud and acknowledge it. This is Paul's third time taking the exam. So third time is a charm. Anyone can do this. And I'm not saying that to be deprecating to Paul. He just works his tail off, and anyone can work that hard. So.
Yeah, I don't feel bad at you mentioning that. Matter of fact, I want people to know that, it took me 3 times that, I have over 15 years networking experience, and, I stuck with it. So if someone could take something from that, that's great. So.
Yeah. Wow. Awesome, man.
I am so excited. And just to hear that you finally passed, it's like, you made my day. Thank you.
Oh, thanks. I appreciate it, man. Appreciate it.
No kidding. Yeah. Well, I do want to put Paul on the spot here and let you guys ask him a couple of questions since he is our most recent test taker here. One of the first questions I have for you, Paul, to kick things off, though, is looking back on how you prepared for the exam, what is the one thing that you did that if you had to start from scratch, you would double down on? What's the one resource or tool or technique or anything like that you would double up on next time?
The thing that I would double down on, well, actually, to be honest, and I'm not trying to be funny here, but I was already doubled down because I was going so hard at it. But what I would change was the way I started out, because when I got to OSG, I attacked it from a linear perspective and went through chapter by chapter. And I know people learn differently, but if I had to do it all over again, I would do it domain by domain, if that makes sense. Because my learning style, I think it would have been much better. I would have, kind of pooled the sources of information, kind of together in a more, better grouping.
More structured for studying.
Yeah, more structured. Because even after I got done with the OSG, I had to go back through it again, but through a domain type perspective, and I grasped the information much better that way.
Interesting. Okay, boy, that's great advice, Paul. I like when it's that specific. Yeah. Who else has a question for Paul here?
Paul, did you do it in the morning or did you do it in the afternoon? Were you kind of strategic about that?
Well, good question. Like I mentioned, and Josh mentioned, I took the exam 3 times. So on the first 2, I took it during the morning. On this third one, I had to take it in the evening, basically, because that was the last slot left. And yesterday was the last day I could take it for the, to have the voucher to be able to take it again if I failed it. Nice. So that was the only slot left. So my test was at my exam was at 4:45. I left there about 7:30-ish. So I took it in the afternoon.
So very, very strategic then, pretty much like the last possible moment to do it. That's great.
Well, yeah, that wasn't so much strategic on the last one. I had to accept what they had left,
sure.
Right?
Yeah.
But yeah.
Do you think it made a difference, like between doing it in the evening and doing it in the morning?
That's a good question. Well, it gave me more time to study during the day before I went to go take it. But other than that, not really.
Okay.
Not. I mean, I would say it depends on the individual. Like if you're a morning person or if you're more of an evening person. But I don't think it really varies. But I guess it worked for me because I passed it.
Yeah.
I didn't plan it that way, but it, hey, I'll take the win, So, yeah.
Awesome. Saravanan, you got your hand raised. Go ahead.
Yeah, Josh. Thanks. Congrats, Paul.
Thank you, Saravanan. Thank you.
Question: like, what was the different approach that you took in the exam than the previous ones?
Another good question. Well, I could say, after the first 2 exams beat me up pretty severely, and I'm not joking about that. My outlook wasn't good going into the third. I'll just be honest. It was better, but I didn't have a good outlook going into the third. And my reason for saying that is that I'll say it again. I wasn't someone coming in off the street taking the exam. I have a good bit of knowledge in networking and stuff like that and other domains. And from what I saw from the previous 2 exams, kind of knocked my confidence down to 0. And it wasn't the subject material. And this is one advice I'll give to everyone in the group. If there's any takeaway, the structure of the exam and whoever structures these exams and configures the questions, be very careful and be very familiar with that questioning structure. That's what got me, is the form of how they ask the questions that don't make sense. You don't know what they're really
about that, Paul.
Yeah, so, and I think you've covered this a couple of times, Josh, in some examples as far as the psychology behind the test makers, right? These are not people who are necessarily have the background in this field. So some of the questions may come out like an alien wrote it, and it doesn't make sense. It's like they're grabbing piece from one question over here and, oh yeah, let me grab this and put it over here and then kind of read it out. And, grammatically it may sound okay, but from an engineer or networking experience, it doesn't make any sense. And so when I went in there, I was still faced with that. Now, my hump to get over that, my advice would be to hammer away at these exam things like Thor that have these question structures, keep hammering away. Well, first of all, know the subject material. Don't just go taking exam questions you don't know what the subject material is. But once you have a good grasp of the subject material, hammer away at these questions. I'm talking about thousands and, well, you know, a good bit of them until you get used to that format. So when you go in there, you're not staring into the first question like they're in the headlights, like I did a couple of times. Okay. And, you know, I'm just going to leave it at that.
That's a good point. Yeah, we could deal with some more ambiguous questions, maybe, or some differently structured questions.
Yeah. So which practice like test like that mimics it?
I did Thor, Boson, and the OSG, and also those were my three main. I would cycle through those, and you know, once I did the OSG exam questions, I go to Boson. Once I went through Boson, I'll go to Thor. Once I got through that, I'd cycle back through and keep just cycling and hammering away at those exam questions.
Awesome.
And you know, once in a while, like if I'm out and about, I have the whatchamacallit on my phone, the whatchamacallit, Learns app. I have that on my phone as well as the ISC squared one. So I would use those as well when I'm just hanging out or waiting for an appointment or something like that. Yeah, you got to put your time in on this thing, man. And but my takeaway would be get comfortable with the exam structured questions.
Nice. Adam had a question real quick. What is OSG? Do you have a link or something, Paul, you could throw in the chat for us?
Oh, I'm sorry. That's the official study guide. The ISC.
Oh, sorry. Okay.
Nice.
Yeah, sorry about that.
Thanks for catching me up on that.
That should be common knowledge. Sorry.
Could be CB. Yes.
Well, some people don't refer to it like that, but I got it.
Let's take one more question. Who else has one more question?
One last question, just like how about the timings? Like, is there any wordy question, like, long questions? Are we able to manage the timings?
So I've never been able to manage the timing. I'm just being honest. When I tell you on the two exams, even this third one, the first question, I'm like a deer in the headlights until I have to calm myself, take a few breaths, look at the question again, and read through it, and then restructure it to find out what it is that they're truly asking. Take a deep breath, because when I was on question 30, I wasn't looking at the time. I didn't want to look at the time, to be honest. But when I looked up, I was like, oh, man, I got to step it up. And that's when I started stepping it up. And actually, I got to like 100, and I had some time to spare. I had a good bit of time to spare. I had probably, I forgot how much. So then I started slowing down some more and taking more time with the question. So it's up to the individual, to be honest.
Were the questions long or were they regular size?
So that's a good question too. That was one of my complaints on when I first took the exam, how long and complicated and thing they were. I think I won the lotto on this last one where there weren't as many long convoluted questions.
Did you get a cliff test?
What's that?
Did you get a cliff test?
A club test?
You got an easier one too.
Well, I mean, it wasn't easy. It was easier than the first two. It wasn't easy at all. It was easier.
Nice.
Yeah. But Josh, not to take up your call, but I have one quick question for you. Because to become a member, they said, you have to get like an IC2 member. I was wondering if you can vouch, or do I have to get someone else?
Yeah. Chat with me offline about that if you would.
Okay.
We have a process that we're building out for that, and we'll get you squared away. No problem.
Yes, sir. All right. Thank you, guys.
Cool. Oh, dude. Congratulations again. I'm so stinking happy for you. We'll move on with the session tonight. If you have further questions for Paul, you can ping him on the Skool community. He has been so involved and so helpful there. Congratulate him again. You are welcome to hang out to Paul if you'd like to join us and give us your CISSP perspective on some of the questions and answers, but I don't blame you if you want to go hop off and take a nap or anything.
Yeah, I might jump off early because this thing has been beating me up. It's took up a chunk of my life.
Oh, man.
So, but yeah,
I hope you get to rest. Yeah.
I'll still be on the calls going forth in the future just to kind of, help out. But I'm not going to take up you guys' time. I appreciate all the feedback. Thank you, guys.
Good work, buddy. Cliff, yeah.
So, as many may or may not know, that October is Cybersecurity Awareness Month.
Oh, yeah.
And how many of us or how many of you are getting ready to take your CISSP or other security certifications? I'd like to know that.
Yeah, that's a good question. Because we have at least a couple of people have told me they're scheduled for October. Is anyone on this call scheduled in October?
I'm scared to say it, but I take it on Friday.
You take it on Friday. Yes.
I don't want to I don't want no negative energy or bad juju.
You're not going to get any of that here, Sandra. You know that.
Good luck, Sandra. I wish you the best. You
Thank you. It's good to hear that you got it. So yeah, congratulations.
Good luck, Sandra. Good luck.
Thank you. I need it.
Past and during Cybersecurity Awareness Month. That'll be an easy one to remember. Okay. Well, there is an icebreaker poll launched just to, for some of the new people that we have on the call here. First of all, welcome if I have not met you. I see we've had a couple people join in the last few minutes as we're celebrating Paul here. So the poll section of Google Meet is what we'll use for some of the practice questions we'll go through today. So the way you'll find that is on the Google Meet bar, there's the activities pane. It's a couple of shapes nested together. If you click on that, you'll see polls. So in the activities section, you'll see polls. You can submit your answers there. And that's what we'll use through practice questions. So today we are going to continue on with domain 4 practice questions related to communication and network security. And specifically tonight, we're going to focus on the OSI model. This has been requested by a few people. So we're going to spend some time going through the OSI model and a handful of practice questions related to it and the rest of domain 4. So before we get started, I want to do a quick refresher on the OSI model before we do our first practice question. So first of all, let's pause. If someone is feeling brave and confident in their understanding of this, would you take yourself off mic? I'm curious as to, big picture, why do we have a model like this? Why do we care about, well, what is this even? Some hierarchy it looks like? Someone tell me what I'm looking at. What does the OSI model help us to do? Yeah, Rebecca.
I'll take a stab at it. So I've been trying to get a bird's eye view of the 8 domains. And in my opinion, domains 4 and 8 constitute the assets that are to be protected in information security. And so it not so, but further dividing that, 8 would be your applications, and 4 would be the infrastructure. And the OSI model helps us understand how each part of the data communicates in the architecture for one level, from level 1 through to 7. So what data and what medium it exists in. So that's just me.
That's very well done, Rebecca. Boy, thank you for that. That's a perfect explanation. All of those different components that she mentioned, I mean, we have data, we have physical devices. How do we interconnect all of those and have them be able to have networked communications? We use the OSI model to help us describe that and to help make those interconnections. Before frameworks or methodologies like this, it would be very difficult to establish a communication with a different vendor if you didn't have these protocols mapped together. So this helps us define the architecture of how the internet really works. This is really foundational. The OSI model is not used as commonly as the TCP IP model that you'll see over here. We're not going to discuss that today, but the OSI model is preferred by ISC2. It's used quite a lot, and it's used quite a lot in troubleshooting. So even though TCP IP is more common in production use or terminology, you'll see this more related to what we're studying, and it's helpful as an additional breakdown of the application layer. So a good way to remember these in order, and I will request that you do memorize them in the correct order. It will serve you well, not just in your professional life, but definitely on the exam. It is worth knowing these in the correct order. So you could do, please do not throw sausage pizza away. You can see it's reversed here just in the description. So please do not throw sausage pizza away. So that's our OSI model. We're going to spend a lot of time talking about that tonight, but it's a lot more enjoyable to talk about it if we have a reason to. So we're going to do a practice question next, and then afterwards we'll discuss it. So the next slide will be a question with the 4 possible responses. You'll be able to go then into, after you've had a chance to read it and answer yourself, you'll be able to go into the polls section again and submit your answer. So I'll launch a poll here shortly for this. It'll just be silent. I'll have a timer on my phone for about 50 seconds. So you just take that 50 seconds to read the question, pick out your answer, and submit your poll. Please don't put anything in the chat. That way we have an opportunity just to have a fresh discussion. Let's see, let me get my timer ready. Are there any questions before I go to the next slide, which is our first question tonight? Okay, we will do a question, and if there are questions after that, we can address them. All right, first question is launched. Okay, you've got a few more seconds left to get your votes in. Cliff says he knows the answer. You're a CISSP now, Cliff. I know you know the answer. You know all the answers, buddy. Okay, nicely done. Nicely done. I'll show you guys the results here. Just about everyone got it. The physical layer, that's the correct answer. The physical layer. This can be a little bit tricky if you read it differently than it actually means. And I can see that someone put the transport layer, and I actually jumped to this initially because the way the question reads, the OSI layer includes electrical specifications, protocols, and interface standards. We're actually looking at electrical specifications, electrical protocols, and electrical interface standards. The reason that can be confusing is protocols is listed here. If you didn't kind of intuit that electrical was applied to this, then the transport layer would be spot on because we're absolutely dealing with ports and protocols at that layer. So that's just an example of being really cautious when you're reading the question about making sure that we understand what it's asking for here. And yeah, this is exactly correct. We're at the physical layer. This is where our bits and bytes go, our physical medium. And we need a way to define how that translates over the internet. So we'll move on to question 2 here. We'll get into some examples when we get some challenging questions for us. You guys all pretty much understood that. Okay. Question 2, go ahead. Nice job. A few seconds left. Okay. Well done. Good deal. We got just about everyone got it. The transport layer is what we're looking at, the transport layer. So we're looking at segmentation, sequencing, and error checking. And they give us a couple of protocols as well. So the way we're going to look at this tonight, we're going to do one other practice question, and then we're going to go look at a visual of some of this going on and to see what is happening at each layer in here. So what I want to call out here is these are our verbs. This is what is going on at that step. We're looking at segmentation. We're sequencing our packets. We're doing error checking to make sure the packets that we got are correct. So this is what is happening. And now we can go look at some of the protocols that layer is associated, that layer is associated with. So there's categories because you could think of things like devices. Devices will be more common at certain layers. Sometimes they can cross over multiple layers. But we'll look at this from a couple of different angles. So we have what is going on. We have the protocol involved. We'll look at the devices. And we'll look even at the kind of the packet frame segment layer of this too. We'll do one more practice question here. Does anyone have a question before we move on though?
I do. The error checking, in my head, I was thinking presentation layer. I am the person who voted for presentation layer because I was thinking input validation.
Ah, yes. Excellent.
So how are we saying when we're answering the questions that everything has to tie together? So segmentation and sequencing and the error checking has to tie with the segmentation. Is that what we're saying?
Yes. So one of the common traits of CISSP exam questions is they want you to look for the best answer. And the answer that addresses the majority or all of the requirements. So here, you're exactly right. Error checking. Let's just pause for a moment. So Rebecca brought up the error checking can happen potentially in the presentation or application layers through input validation. But the input validation takes place, we have our code that's running an application. So we can have input validation going on where the application is receiving that data, and then the error checking typically might take place at what's the layer right before the presentation layer. So that's an example of error checking that absolutely is at those higher levels. This type of error checking is specific to the packets or frames that we're receiving here. So yeah, great call out. We have an answer that, a key word here, error checking, that could show up at some of these higher levels. So good call out on that, Rebecca. Does that make sense from a CISSP exam perspective of why the transport layer is what we ended up choosing?
Yeah. Yeah, but I have to go and just like Paul was saying, not just assume, but fully digest each of the domains. I'm starting afresh from, I've been pushing this exam off on and off. I don't have a date, but I'm now committed. And I'm, with my restart, I'm on domain 1 and trying to, like I said earlier, fully understand what I'm reading.
Excellent. Yeah. Well, we have some videos posted of some of the questions we went through in domain 1. So you're welcome to check out the YouTube videos that we have because those might be helpful as you're going through those domains.
Thank you.
Yeah. Okay. Get ready for question 3 here. And go ahead. Okay. Nice job. Boy, I'm not tricking you guys very well on this. Good job. Almost everyone got this correct here. Application, presentation, and session. Those are the layers where we see data streams here. So let me pause. What is a data stream? Does anyone have an answer for us offhand on what a data stream is? What are we even talking about in this question? I'll give you a clue. You're staring at an example if you're paying attention.
I can.
Yeah, Venkat, I would love to hear from you.
When you talk about data, it is the fully completed packet. So at the physical layer, you start with packets, bits, data, then you go to packets and segments. So data streams is the completed flow of all the final thing that shows up on, say, you're browsing the web page, and all the bits that forms and get presented on the top layer or the top 3 layers is what data stream is.
Yeah, that's exactly right. These top 3 layers, and that's what they are. We, like Venkat said, we start at the physical layer. We start working our way up with frames and then packets up to segments, and then we get to a session. Now we have a session that's created. In that session, we're passing data back and forth. We have that connection that's been started. And then presentation and application, it's the same way. So you're watching this presentation, you're watching this video. Well, it's a data stream that's going on. That's an example of a data stream. If I go download a file from the internet, that transaction is that data stream that's going on. I have to have a session first. That's the first point where we have a stream that's starting. Then there's the presentation layer where that data is being readied for presentation, and then the application layer, either where I'm accessing that form or when the form is getting, where I'm actually getting to view the form. So that's data streams here. Let's take a pause though and go look at, let me back up a slide, no cheating. Okay, let's go take a look at this together.
Josh, sorry, can I interrupt?
Yeah, please do that.
So with the OSI model, is it wise to think about it in terms of a single website and all the components that would make up that website, or is it better to think about it as the internet entirely?
Yeah, good question. I would say, not to be too cheeky, but I would say it's more like a journey. It's how does a packet traverse the internet? It's almost, I wouldn't call it a roadmap, but it's how to use a roadmap. It would be like an instruction guide on how to use Google Maps almost for the internet. But let's walk through this because your example isn't far off, but I think it'll make more sense when we look at it through the journey of a packet and what's happening there. But pause me or stop me if it doesn't make sense after we go through this. So we mentioned, this is just a graphic from the internet. We're going to work on our own things, but let's look at a couple of things that they list here in this graphic. So the end user layer, that's exactly right. We're all on a web browser or on an application, an app on our phone. That's where we get to actually interact with the data. This is where the data lives in use here. Let's see, we have a couple of key protocols. Domain name service, we'll chat about that here in a little bit. We have HTTP. So when we're using these protocols, I'm on the application layer. Presentation layer, we start to compress and maybe encrypt data. This is also where syntax gets important. We're starting to communicate that data and prepare it for transport somewhere else. The session, this is our connection. When we're using the OSI model, when we're talking about networking in general, we're networking to something. So we're never just have a single point. We always care about the relationships between something. This is why if you study the OSI model, just like this, you miss the critical aspect of it actually is a journey that it goes through. This is helpful from a troubleshooting perspective and identifying what layers things are going at, but things are going through the layers in 2 different ways. So we'll explore that here in just a moment. The transport. So you can see we broke down from the transport. We're no longer doing data streams yet. We're trying to actually communicate that data to have that data traverse the internet and get to the correct spot. This is where we are setting up the connection that'll support a session. So to do that, we start to bring in ports, protocols, and services. You see TCP and UDP on here. So in TCP, we'll use segments, packet segments, and then UDP is connectionless. So we can just blast packets. We don't expect a return response on here. So instead of segments, they call them as datagrams is what the term that they'll use here. The network level, we're using IP. We spent quite a bit of time working on these, the network and data link layers the last couple of weeks. The network layer is IP. The data link layer, we're still working with MAC addresses here and with frames. And then our physical is our, well, physical infrastructure, which you guys can understand there. So, Cliff, yeah.
Pardon me. One thing that has stuck with me through the years between TCP and UDP is like if you address a letter to somebody, you have a return address on there. However, for UDP, it's like sending a postcard. There's no guarantee it's going to come back. There's no checks or anything like that. So hopefully that helps.
Yeah, that's exactly right. Great call out, Cliff. TCP, we need to make sure and validate that the stuff actually got where it was. We need to validate that everything we sent was actually received. This would make sense for something like email. So it would not make some sense for something like this, where it's a broadcast stream, where you access it, but I don't expect to get a return packet of whether you saw every frame of what we're talking about. So this video is going over UDP. So great call out on that, Cliff. Yeah. So let's walk through this journey, and we're going to use our friends Alice and Bob here as our example. And we're going to start with just a simple example of sending an email of what happens behind the scenes and talk ourselves through the OSI model. So Alice is going to send an email to Bob. Here's your email. It starts out at the application layer. What is Alice doing in the application layer? What's happening to her email? Someone tell me about that. Let's just stick with the application layer for Alice right now.
She's writing it?
Yeah, exactly right. Yeah, she's in Gmail. She's writing the email. She's interacting with the application there. It's the user interface. That's perfect, Adam. Okay, so now she hits send on that. All right, now we have some things that are starting to come into play here. We might encrypt that data potentially. We might compress it. This is where we are starting to prepare that data for actual transport. The user has submitted this online. What do we need to do with it? Not necessarily from a coding perspective, but what do we need to do with it to get it ready for transport? Sessions. This would make more sense if instead of Bob, you thought of Bob as a mail server in this sense. This is, we need a session created for this transmission to actually get to Bob or get to his mail server. And so we start to bring in, this is a connection point. There's a lot of the, let's see, we'll come back to session a little bit more later. So then it goes down to the transport layer. Cliff called out that we start to have TCP or UDP. How are we going to transport this data that the user has submitted, that we've prepared? Now we've established a session, and let's get it ready for transport. So we have to have ports, protocols, and services. How are we going to get it to where it needs to go? What is it? How does the internet need to identify what is going on with this packet? Which is exactly what happens. We translate it into a packet. So there's an IP address going on here. At the network level, let's think about the data that is being transmitted at this stage and the different things that are happening to the data as it moves down the layers. So we here decided it was TCP, we picked a port number, and then we went down here. Whose IP address gets posted on this email? Whose IP address goes on there?
Alice's?
The source?
Yeah, it's both actually. So we'll have both the source and the destination IP address. So we'll have Alice's IP, but let's think about this for a second. We're trying to establish a connection with Bob. How the heck do we know Bob's IP? How did we get that information? What protocol happens up here that helps us resolve an IP address to Bob's domain or his email address?
Was it the ARP?
Say that again, Annette?
Was it ARP?
Oh, not quite, not quite. Who else?
Was it the DNS?
Yeah, DNS, domain name service. Exactly. So domain name service, this is also something that lives at the application layer. When Alice is preparing this email to send, she puts in Bob's email address. She doesn't know the IP address of his mail server or anything like that. She uses his name or his email address, his domain. So we use DNS records on the internet to map that to an actual IP. So DNS at this layer starts to prepare information that we use when we do this. So when the data gets down to the network layer, we apply a source and a destination IP address. So Alice's IP, this is her public IP address, and then Bob's mail server's public IP address. Yeah. Does anyone have questions before I move down to the data link layer? I know the network and transport layer especially can just be a little tricky because there's a lot happening there. It's going from user to now we're talking about networks more than anything.
So just to clarify, the IP address for the destination it's not like Bob's computer, it's like his email domain.
Yeah, exactly. That's exactly right. It's how he's accessing that. There, we'll go through an example where it's not necessarily a mail server, but Bob, when he logs on to check his email, what do you think is going on in the background? I suspect this very similar process is going on as Bob accesses his email application, and it goes down to the data center wherever that email is actually stored and gets brought back up to him. So there's this happening multiple different ways as we're communicating. But yeah, you're right on the right track there, Adam.
So Josh, I know we are a transport network, but on the session layer, what is that socket and WinSock? Is that, I don't know, I've heard that before.
I'll be honest with you, April, my understanding of sockets is not strong. Does anyone on the call have more experience or exposure to that? Because I do not have a strong answer that I feel comfortable giving you.
Can I take that?
I would love that if you did, Anket. And I'm jotting down that as a question because that's a really good question. So please, yeah.
So the question was, what is the sockets WinSock in the session layer, correct? So in a session layer, what happens is, in the previous example about sending an email. So when a communication is established from one computer to the other, say from the user's email to the email server, there is a path or a connection that is established. That connection is a virtual connection. It's not a physical connection like a cable connecting two pieces. It's a virtual connection. And that connection it lasts for some time. So when you open your web page and say google.com, so there is a session that is created from one of your port, your PC. It's usually 443 if you notice. And that connects to the Google server. So there may be many people connecting.
Okay.
So that one session of yours, which is connecting to the Google server, is a session. And that session is called, that assumes a port number. It's a random port number that is assigned. And that is a socket. Windows, it is used. The WinSock, it is called. API is when one API client is talking to an API server, that is one session, API session. So session is a temporary connection of two resources.
So is that like the tear down when it's over? It tears down, the session is complete?
That is correct. Of course, there are some timeout. It's not immediately disconnected. There is a timeout that can be configured.
Yes.
Say if there is a video, you need longer timeout, but it's a configurable. But yes, that is right.
Okay, thank you. I got it.
Boy, Venkat, that was an excellent explanation. If it's okay, I'm going to try and rephrase that, but please correct me if I get anything incorrect. It's important to me that it's accurate because you understand more about this than I do. But let's look at this from a reverse perspective when we're going up the layers here. So we start out physical. At the data link layer, we have a MAC address. At the network layer, we start to add an IP address. At the transport layer, We mentioned we have port numbers that get activated, starting to get into the service section here. And then sessions refer to when we actually use that port to establish a session connection with a server or a resource. Then that session connection, that random float number that's assigned to it, that's the socket. That's the socket. Did I understand that, Venkat?
That is correct. That is correct.
Okay.
So
Really well.
Instead of web server, any application that you take, if an application wants to talk to another application, it could be a software, your TurboTax, for example, connecting to your TurboTax server, your web server connecting to another. So everything needs a connection. So that temporary session is not like a physical cable. So there is a temporary saying, say, for example, saying a TCP IP, there is a server that's saying, hey, I am open on 443. Anybody wants to talk to me can connect to me on 443. And there is a client that connects to 443. And when he creates that temporary software connection, that is called a socket. And the sockets are used by software. When writing software, you write a software saying connect on this socket and tear down this socket in that language. So yeah.
Fantastic. Boy, that is just a tremendous, tremendous explanation. Boy, thank you. You need to be a teacher a little bit. It will help us out here. That was wonderful. Thank you. I feel like I understand that better than when I was studying for my CISSP. So well done. Okay. So thank you for explaining sockets to us. All right. So let's look at, we'll continue on with our example here. So Alice has sent her message. She's interacted with her email application. It's gotten it ready to, it's kind of packaged so that it will be ready to present when it's unpackaged. We have gotten a session connection started here, or getting it ready, added the information that we would need to, I guess, to create a session. Transport layer, then we bring in the port numbers and protocols. Now we have packets, and then we're going to go down to the MAC address. So what is actually going on for Alice at this stage? Well, when she is sending this packet out, it's now at her device level here. So we were at the application level looking at her browser. Here it starts to move down in packaging until it gets to here, her network. So her network interface card. Here we're starting to look at what her local area network is. We can communicate on layer 2 using MAC address. So at the data link level, whose MAC address gets listed on this email or on the packet, or I guess the frame now is what we're at, the frame.
Alice's.
Yeah, so Alice is going to list her MAC address. What's the destination MAC address, you think?
I mean, do we need to know it?
This is tricky. This is tricky because Adam's right. How on earth would we know what MAC address, because this is device level, how would we know what MAC address Bob is going to use to access this? Adam's right. We don't, and we don't need to know. What we need to know is how do we get it one step closer? And that's what we're going to start doing here. So the source MAC address, like Adam called out for us, is going to be Alice's. The destination MAC address is it's going to be its next hop. So let's take Alice's example. She's sitting at home and she sends it. The next hop for her is most likely her home router. You could call this her gateway. If you were sitting in an enterprise, this could be like a layer 3 switch or another router. It could be potentially a switch or a hub as well at this layer. And then it goes down to the physical medium. So this is on its actual cables, or the cables and Ethernet here. So it's going through the transport, goes on this Ethernet here. We're going to talk more about this journey here in a minute, but let's keep it simple for now. So let's unpackage this now. Alice has sent an email. We've watched the data go from the application layer where she's typing it in all the way to the bits and bytes, leaving her Ethernet cables. Now it gets to Bob where he's going to access this. So first, the information was going to need to find out, okay, I'm on a local area network somewhere. How do I get to where I want to go? Well, it's got a source MAC address, and it's going to continue that next hop, that mentality here. So a router gets it. It looks at what's the next hop that this wants to go to, and it has a destination IP address. Well, we're at a layer now where the MAC address and IP address start to get linked up. So we have an IP address now. What's the protocol that helps us get an IP address from data link up to network? We discussed one example last week, and it's been deprecated by something more common. How do we get IPs? We could do this potentially through ARP, Address Resolution Protocol. That was a deprecated version we talked about a good bit last week. We can also get this through DHCP as well. Find out what IP addresses are there. So then we move to the transport section here. We're now getting this more and more packaged up and ready to, or excuse me, unpackaged at this layer. So we're unpackaging it and starting to set up a session because we have all of this information on how to set up this up to the application layer. So presentation, we're going to start decrypting it behind the scenes. We're going to start translating the syntax to get it ready to unpackage into whatever application Bob is going to use. If he's going to use his email, he'll log into his email accounts and have the application layer that he'll be able to actually view that content in. So let's pause there for a moment. I'm sure some people have some questions, and we're going to, as we do that, we're going to use a different example and use a file download. So instead of reaching out to a user, we're going to go talk to Bob, or just download a file instead of talking with Bob. And we're also going to bring a router into the mix. So we'll see what happens to the information at these different layers when we have to go through different hops. So who's got some questions we can start out with here?
I think when it comes to the email going up the chain to Bob, I think in my brain, like, it doesn't really go up. It's more that he logs into his email and then sucks it to him. So it's almost like he starts at the application layer and goes down to the physical, I guess, to suck the email to him.
It very much occurs that way. Yeah, it's because that's exactly how it's happening from Bob's perspective. He logs into the application, has information that's prepared for him to access it. So he is experiencing all 7 layers as well. From an individual packet perspective like this is the journey that it will take. Bob might initiate that session or journey from his end, but the arrows would be reversed from his perspective. Again, it depends on the perspective. Bob is using, exactly like you said, arrows reversed. He's starting at the application layer, but our packet, our data is coming up the stream so that he can access it at the application layer. So great call out, because there's multiple ways that this is occurring in the background.
So I guess his email would sort of sit at the presentation layer until he's ready to collect it. Do you think?
Yeah. So if this is consider like an email server, something like that. So we need to transfer information to his server, and then Bob can log into and access that whenever he needs to. So this can go over, physical layer, data link layer. Where am I going? Where's Bob's email server? Okay, I have an IP for his email server because we use things like DNS. Now it gets transported and we have a session with that email server. And then this message can get stored on that in the email server, but that kind of almost resets it. So we have data that's going up to the application layer. So yeah, I don't know if that makes more sense, but we'll go through a couple of examples of this, but great call out on that, Adam.
Can I make a comment?
Yeah, please do, Venkat.
So at the top, you have mentioned data encapsulation. For this example where you're talking about the mail, on the left side, I think it would make sense to say encapsulation, and at the right, it would make sense to have it as decapsulation.
Yes.
So data encapsulation is when you start create, and then decapsulation is it strips the layers till you see the email eventually. If that helps.
Yeah, great call out. It's peeling out the layers.
Yeah.
As we go down through here, we're going to add another layer, add another layer, add another layer until we're down here. At the frame level, we have a frame that has all sorts of different data that's in here. Data about the network, transport session, all these different layers. And then we come here and we start to unpack those layers. We decapsulate them. We take it out. Okay, I know what the data link network layer is. I have that information. Now I need the network information. So I decapsulate again and get access to that info. Great call out, Venkat. That's a wonderful way to explain that. Who else has some questions on this?
Well, I have a quick question. So, like, why? I'm trying to unpack it because I get all the layers. It's just that when we send an email out, we're at the application layer, and it's going to identify the sender and the destination, source and destination with the DNS. I get that. Then it goes to this presentation layer to break down the format. Then it goes to the session to create a session with, I guess, the port we're going. I just don't know why it waits to the network to start the IP address. Like, shouldn't all that be up there? I'm not trying to change anything around, but just not make sense to me.
Yeah, you're on the right track, because here we need to resolve to the domain example. So the domain address, we need to resolve to an IP address. We don't necessarily need that IP address until down here, unless there's some data processing that takes place here. But you're right, we don't need the IP address until we get down to the network layer. Here we're working with the data. And then down here, we start to get into, let's now transfer the data.
Okay.
Yeah.
Okay, so we're packaging it up there, and then we get to, all right, let's get ready to transmit it type thing.
Yes, yes. This whole application layer deals with a lot of data. Here we're transmitting the data, getting it to where it needs to go. Here we're using it. We're actually getting to view it.
Yep, I got it. Thanks.
Okay, excellent. Well, let's do another practice question here. We'll go back to that visual here in a moment, but let's get another practice question or two under our belts.
I was trying to ask a question.
Oh, yeah. Rebecca, go ahead, please.
Yes, so to me, it seems that multiple layers of the OSI are happening simultaneously. So we're talking session ID being, what number was that? 5, the session, and however, at the application layer and even the presentation layer, when a person is connecting, right, a session ID is created. So once the user attempts to make the interaction with the application, there's a session ID created. Where that not so, there wouldn't be the issue of someone else stealing someone else's session ID to make a connection. And then with your example here with the email, I'm thinking that's a different session ID for the activity itself, the send of the email. But
you're exactly right, Rebecca.
Yeah. So that's how I'm looking at it. That's it's not the activities are not unique to one layer, but that's several are happening at there are multiple activities happening throughout the layers that may one might be tempted to isolate to one layer, but it's simultaneously happening in other layers.
Yeah, it can absolutely look like that. It very much looks like this is all happening at the same time, especially since this is happening thousands and thousands and thousands of times, almost simultaneously. With every packet we send, this is its life cycle here in transmission. You mentioned the idea that, yeah, the session does create something for us to have data streams. Data streams living at the top 3 layers, and these are just continual data transmissions now that we have a session established. So in that sense, yeah, all of these are essentially happening at the same time. We have things that are a bit more one-offs. Physical is the easiest to see that because it needs to transmit one time to a destination or maybe get bounced back and forth, but it's transmitting somewhere statically. Versus up here, we're constantly interacting. It's a data stream. So that's a great call out there. Yeah. Excellent. Let's do another practice question here. Get yourself ready. I'm going to pull up my timer. And go ahead, question 4. Keep it up. Great questions, by the way. I love questions. I'm going to miss Paul because he has the best questions. So see who's going to wear his crown or his shoes.
Did you post the question?
Oh, I didn't hit launch. You're right, Sandra. Thank you. There we go. Okay, launched. Thank you. Okay, a few more seconds. I'll give you some extra bonus time because I forgot to launch the poll. Okay, get your votes in real quick. This is a long question for sure. All right, so let's pause. Let's pick out some keywords here. For those of you who are new, this is one of the great things about, one of the great techniques we can practice in making sure that we really understand the question and aren't tricked into any answers. So who's feeling brave and wants to call out a couple of the keywords that are most important for us to know about this?
Broadcast storms.
Broadcast storms. We got to know what broadcast storms are. Absolutely. What's another one or two here?
Same network segment.
Same network segments. So we have broadcast storms on the same segment of the network. Okay, good deal. So those are great keywords.
The answer should be D.
D.
Segment the network based on functional requirement.
That's exactly right. Yes, MD, it's nice to meet you. I don't think I've met you yet, but great to have you here. Yes, the correct answer absolutely is D. We're going to segment the network based on functional requirements. So let's walk through this. You guys all understood this pretty well. Requiring encryption isn't really going to help us with a broadcast storm. We're trying to broadcast information. Typically, we're not going to encrypt that, and it wouldn't resolve the issue anyways. Installing a firewall at the network border. Well, we're within the same network segment, so a firewall won't really help us to do that. Now, enable spanning tree loop detection. Who can tell me why that might not help us here?
I've never heard of that before.
Spanning tree is used when you're connecting multiple devices in a network and like multiple switches and creating VLANs. You might need that, and that will not stop the broadcast.
Yes, you're exactly right. So a broadcast storm is what happens when we're on a network and a lot of devices are starting to do broadcasts. It's normal. Broadcasts aren't malicious. They could be used maliciously in a denial of service attack, absolutely, but that's not what's specified here. It's just that we have a network segment that's having a lot of broadcasts. We call that a broadcast storm when it starts to get overburdened. Sometimes this will lead to collisions in a domain, and we'll have a practice question on this here shortly, but that causes network disruption if we have collisions that go on. And this is something that's heavy networking, spanning tree loop detection. What you need to know about this, so it won't stop broadcasts. This stops a loop in a configuration. It's been, my understanding on this is shaky. Venkat explained this well for us, but if I have a configuration that tells me I need to send information to a data point, but that endpoint has information that needs to send it back to me while we're in a loop. And that can get much more complex if we're in a network that involves VLANs, and these loops can start to magnify. So spanning tree loop detection is a specific technology that we have on, like Venkat said, on switches, potentially on routers as well, to help us avoid these sort of issues. I think this actually is just switches, not routers, unless it's at the layer 2 level 2.
Yeah.
But segmenting the network, absolutely. We have fewer devices, so there's going to be less traffic going on that network. So less chance of a collision or a broadcast storm. Venkat, did you have something to add on that?
No, that is good. Thank you.
Yeah, excellent. Okay, so let's get ready for another practice question here. Well, first, does anyone have questions on this one?
Can I just clarify, you know, when you said the broadcast storm, is it just saying there's back and forth communication occurring on that network? Is that what you're saying? There's an overload of communication? Is that what you
Yeah,
mean by
I couldn't hear you super well, Sandra. So tell me if I maybe misheard you. But yes, so if we have a network segment, potentially has a lot of devices that have broadcast needs, whatever that would be, if they're broadcasting data, and that network just gets congested because broadcasts go to everyone on the network on that network segment. So it's just congestion when we have a broadcast storm. It really is just when congestion leads to a point where we're starting to see network disruption. Did I answer your question there?
Yes. Thanks.
Okay, wonderful, excellent. All right, let's get ready for question 5. And go ahead. Few more seconds to get your answers in. Y'all are doing a great job. Okay. And the poll here and show that to you guys. Good job. Really well done. Layer 3. Layer 3, we're looking at the transport layer. Excuse me, the please do not, the network layer. See, I gotta look at that, use that acronym too. The network layer. So ICMP, who can tell me what command especially on a Windows, Windows or any workstation, what commands do we use to execute ICMP, especially in testing?
Sorry, Josh, before someone answers that, could you just show MD how to use the polls function again?
Oh, absolutely. Yeah, MD. So when we are doing polls, or excuse me, when we're doing practice questions like this, I'll have this slide up with the answers. And then when you want to submit your response, there's the polls section of the activities box. So if you look in the bottom, for me, it's in the bottom right-hand corner, there's some shapes. If you click on that, that's the activities section, and you'll see polls where you can submit your answer. So I have the poll closed right now, but you'll see it open up on the next one. So you can submit it that way instead of the chat. Yeah.
Actually, I am new this group. I joined in this study group yesterday, and this is my first online class or webinar, what you say. And I have joined lately also. Just before a few minutes ago. So sorry for that. I didn't get that. Just now I have seen your pool section.
Oh, no problem. Yes. Wonderful, wonderful to have you here. Would you say your name for me one time?
MD Tanvir Rahman.
MD Tanvir Rahman. Okay, thank you. I'm glad to have you here, MD. Appreciate it.
I'm from Bangladesh.
Bangladesh. Okay, great. Excellent. Well, we'll get ready for another practice question here. Okay, 50 seconds on my timer to go ahead and answer this. This is kind of a long one, so use your time management skills here. Okay, I'll give you a couple more seconds because this one's kind of text heavy. So go get your responses in. We got a nice split vote here. Excellent. Love seeing that. So we are talking about exactly what we were just referring to. We're talking about collisions and jams. When we have too much network traffic going on and we have packets collide, then some device that gets that interrupted will send out a jam signal. And we had a pretty good split vote on this. B is the correct answer. So when a jam signal is received, everyone stops and waits a random period of time. They just have their own internal algorithms that run how they determine, they have their own decision-making process for how to respond to jam signals. So when they get a jam signal, they have a way where they just set a random period of time and then they'll retry that. It seems a little odd that it's just a random period of time, but this is all happening so fast that usually that's enough to just resume communications very quickly on here. So let's look down here. We had a few people looking at option D. Hosts wait for the token to be passed and then resume transmitting data as they pass the token. So we're not really working necessarily with tokens on here. Tokens we will see a lot at the session layer. We did a couple of sessions, a couple of group sessions about sessions and tokens a couple of weeks ago. So there's some great information on some of those YouTube videos where we went through a lot of practice questions and learned about tokens. So I don't know the links for those offhand, but if you look into the YouTube channel, they should be labeled to find them.
So
Then,
for collision avoidance, what do they use? Because I know collision detection is they waiting for the person to come. I get that, but for collision avoidance, I thought they use tokens for collision avoidance.
Does anyone have an answer on that? Venkat, you've got your hand raised. I do not have a strong answer for you on that, Cable.
So one of the things that I wanted to mention is for the answer D, that there is a token ring network. It was in very old days, we used to have token ring network. In token ring network is where you had to wait for a token to be passed. And once you have the token, only then you could resume transmitting. So you have to wait for you get a token. It is saying, once you get a token, it is a permission for you to say, okay, I can transmit. So that's a token ring network.
Okay.
Here is Ethernet network. So when it says Ethernet, it's always anything that says token, it's a wrong answer.
Okay. So for collision avoidance, what is the hold? Because that was collision detection. The question was based on collision detection. What is the process for collision avoidance? Because those two are always confusing.
In collision detection, that means you are listening actively on the wire. So
yes.
You see a sound, right?
Right.
But collision avoidance is in your wireless network. So you avoid the collision by listening to the network and transmit. If there are other, so in wireless, the medium is not wire, it is wireless, right? It's the air. So you look for any available time slot to send your signal. And so if there is no detection there, so multiple clients can send. So you are looking for a pathway that is free, and then you avoid that detection by sending the traffic only when you have that free. So there's no collision there.
It's just watching to avoid.
Okay.
Okay. So Ravanand, did you have a question or something to help us understand?
I think the way I understood is the Wi-Fi has two-way communication. It's not a one-way communication. So in Ethernet, it's only one line, right? So both sending and receiving is one line. So that's that's how you avoid that collision.
Excellent. Yeah. Thank you.
Say that again. Is it two-way connection, or is it one-way connection? Is that what you said?
Two-way communication.
Two-way communication. Okay.
Thank you, Venkat and Ravanand. I really
Thanks.
appreciate how much you guys add for us. You guys really helping out a lot. Thank you. Rebecca, you had a question or comment for us?
Yeah, more of a comment. So when you talk about collision, I view it as the old school telephone lines. where you might pick up and you be listening to someone else's conversation, and or in a meeting scenario where you don't quite have the pulse on who's going to talk next, and each time you open your mouth, someone else is talking.
That's exactly right.
Ah, I like that.
That's
So
crosstalk,
like you
right?
don't know who's gonna talk and you can just spit. Okay,
you keep clashing. So yeah.
got it.
Trying to start communication and not able to because someone else is on the line or someone else is using that network. Yeah, great. Adam, you had something to call it? Thank you, Rebecca, by the way.
I like that. I like that, Rebecca. Thanks. And that's avoidance, correct?
That would be a good example of avoidance, I think, there.
Yes. Okay.
Yeah, Adam.
Sorry, I just wanted to ask, so when it talks about a host, is that like a switch or is that a server or something?
Really good question. Really good question. A host could be any of the above. A host, in the context of a collision going on here, it'd be anything that is on that collision domain, any device that's connected to it. So it could absolutely be a switch. It could be an endpoint. It could be a printer, a workstation, a server. I don't know that we would maybe include a router in there, but that would be only to the extent that it would interact with layer 2. So yeah, you're exactly right on there.
Oh, so like a printer could transmit a jam signal?
A printer, I guess, yeah, could transmit a jam signal. If there's traffic that is going on at that layer, it receives broadcasts the same as any other device, so it could transmit a jam signal. Yeah.
Cool.
Yeah.
And then have a paper jam.
And then very, very nice. I'd pay for your voucher if I could for that. Well done. Okay, let's get ready for question 7 here, and then I think we'll go back to our chart for a little bit. So get ready and go ahead with question 7. Well done. Keep the votes in. Good job. Okay, nicely done. Well, I wasn't really tricking you guys at all there. Just about everyone got it. It's the data link layer. So we're looking at layer 2. So just up from the physical layer, now we start to add a local area network. We use MAC addresses here to communicate. That's exactly right. So let's go back to our diagram and let's just do another example and take a break from questions here for a little bit.
So sorry, Josh.
Yeah,
so would a computer or a laptop sit at the data link layer?
Great question. So a device will help to process this whole OSI model. Their MAC address is what gets added at the data link layer, but they don't necessarily live anywhere. The network interface card of the device is what facilitates these two, the network interface card and then the MAC address on your hardware there. But they there's a lot more going on there. They are the devices at that level that you might associate it with, Phil. That wouldn't be inaccurate to say that.
Thank you.
Yeah, good call out. Okay, so let's look at this a little bit differently. I'll still use well, no, I made this. This is supposed to be a frame. Pretend it's a frame. We have Alice, and she wants to go download a file. And we're going to put a router in our way here because this is more realistic. We're not just Alice and Bob talking and they have one single Ethernet cable connecting their 2 workstations. If we're going to do anything over a network, chances are we're going to run into a router pretty quick. So Alice wants to access some file. She wants to download it. Let's say she wants to download a file from Google Drive. Who would tell me what is likely going on at the application layer for Alice as she is starting this process of wanting to download a file from Google Drive?
Looking for the file?
Yeah, she's in her application. She's in Google Drive. She's looking for the application. She's getting ready to hit double click. Absolutely. Okay, so she hits double click. She's starting to send this request to download this file. So her request is getting packaged right now. The request might be getting encrypted potentially. If this were something like an API, we're starting to add in data for what we need to actually communicate, what we need to include in our API request. So then the session layer gets added in here. Oops, grab this. So now we go to the session layer. We're starting to add in the data that we're going to need to start a session with whatever server is holding that information for us, our Google Drive server, wherever that is. And we get that just behind the scenes. Google is navigating with us to help us resolve the IP address of that server with the domain, which is what starts to happen down here. We start to tack on what ports or protocols we're using. Now, ignore the example of Google Drive. What's a protocol that you would expect to see for file transfer?
TCP?
TCP. What would be a port number that you might transfer files on, a common port?
8080?
8080? Yeah, could be 8080. Yeah, we have protocols like FTP or SFTP as well. And that's what we'll start to here. Hey, April, go ahead.
Port 20.
Yeah, port 20, exactly. So we'll start to assign this here. Now that's not the correct example in the instance of going to Google Drive, but understand this is what's going on in the background. Okay, now we're going to turn this into a packet. Alice has interacted with Google. Google is working behind the scenes to prepare her request. They're getting it ready for transport. Now it's starting to leave her workstation, and we append her source IP address. So this is Alice's public IP address, and then her destination, where she's going. She got this again back up here through the DNS, domain name service. So at this stage, we now have packets. Packets have segments. So let's talk about this section just a little bit more here, because we have data that's being transmitted. Now, UDP, well, we've touched on this earlier, is connectionless. We don't need a connection. I'm just going to throw data at you as fast as I need to. I don't need a response or confirmation that you got it correctly. So that's UDP. TCP is connection oriented. When we send a packet, we get a packet acknowledging that that's the receipt of it. So we can start doing things like error checking, validation on that sense. You can see, let's see, what was the other piece that I wanted to touch on there? That was the main point I wanted to touch on there, I think. Okay, so now we're moving down and we get I was going to talk about sequence numbers as well. So we have our data and we need to split it apart into different segments, because we can't just send one gargantuan packet with the email in it. That's certainly going to have a collision because it'll take up our line for a little minute. So we break it down into segments. Those segments can have sequence numbers, so that on the receiving end, when I get these packets, I know how to organize them. And we'll see an attack here in just a minute if we have time that takes advantage of that. Okay, so we have packets that contain segments. Now we're going to take that packet and we're going to encapsulate it. There's that word here, encapsulation. So we're going to encapsulate that packet inside of a frame. And that frame is going to have the MAC address of Alice's workstation and then the MAC address of the next hop, wherever that's supposed to be. So her protocols on her machine have determined what's my gateway, what's my next hop, where do I go next if I want to talk to the world? And then it goes down to the physical layer. So now it gets to a router somewhere. The router is going to help find out where it needs to go. So what information does it have at this stage? So it gets to the physical layer and goes to this router. Let's pause. How does the router know what to do with this? What does it have to do in order to get access to any information that it needs to know what to do? What's the word?
Would it be on the frame?
Yeah, so it's going to decapsulate this exactly so it can get to the frame. So when it gets the physical bits and bytes, it's going to take those and it's going to start processing them and it's going to put it up here. So exactly like Adam said, we're going to start to get the frame now. So the router has the frame. Well, what's in the frame? Well, we have the source and the destination MAC address. We can check to see, is it on our local network? The router can check that. Okay, it's not on my local network. I need to unpack it a layer further. So I go up to the network layer. I unpackage this, I decapsulate this, and I get the IP. Oh, now I have a source and a destination IP. I'm a router. I'm pretty good at that job. I don't really need any of this other information. So I'm going to, now that I have the IP, the source and destination, I'm going to leave the source and destination IP alone because I got what I needed. I'm going to put it into a frame. Now I'm going to start encapsulating it. You can see it's starting to go down the OSI model layers. So it goes into a frame. What source and destination MAC address get put on here as we encapsulate the frame? What is the new source and destination MAC address here?
Are we encapsulating or decapsulating?
Here is, we're going to encapsulate, and we're going to put in this frame what the MAC address is. So I'm curious what source and destination MAC addresses we're going to use at this router.
Well, would be Alice's, source and MAC to, would be the MAC that we're going to, right?
Yes.
The destination MAC, right?
Exactly. So this is the tricky part here. The network layer, the information that is in here, does not need to change. We're going from a public IP, Alice's public IP, to Bob's public IP, the data server's public IP, wherever that is. That information stays the same. Endpoints like routers will need to decapsulate in order to see that information, but then we can work with the data link layer here, because the router needs to know what's the next hop. The data link layer helps us with the what's the next hop. So it'll send it to its next hop, either on layer 2, or if it needs to, it'll send it on layer 3. But now it'll recapsulate it or encapsulate it again and replace the MAC address. So it'll now have its own MAC address and the MAC address of the next hop on here. So it knows where it's come from, and it knows where it's going. When it gets to that next router, pretend I'm, here, I'll just duplicate it real quick. When it gets to the next router, it's going to do that same exact thing. It's going to, first of all, I'm just getting bits and bytes. I need to look at the data. So I need to translate this into a frame. I need to go to the second layer. Well, I can look at the frame and see, is this on my local network? Yes or no? If it is, great, I can start the delivery process. If not, same deal. We need to go up to the network layer to find out what's the IP address that I need to go, because then I'm just going to send it on to my next hop that I usually take. So the MAC addresses is going to be what is the last hop and what's the next hop. It kind of helps you give that bridge between the physical devices, the physical routers or network interface cards that are helping us to accomplish this. So
is it, sorry,
yeah, Adam, go ahead, please.
Is it collecting information from each hop, or does it kind of like drop off information as it goes?
That's a good question. That's a good question. So the simple answer, and I'm going to say, first of all, I have about 80% confidence on this, so take it with a grain of salt. The simple answer is no, but we have things like stateful firewalls that are session aware that can help with those sort of things. So simple answer again, no, but there are exceptions when we bring in other technologies. So again, my confidence level is about 80% on that, Adam, but I hope that kind of helps.
I'll take it. Thanks.
Awesome. Okay, so we're after this file. We've gone through a couple router hops. All right, this router gets it. It goes to the data link layer. Oh, I recognize that MAC address. It's in my ARP table. So I'm going to pass it up to the network layer. I know the IP. I can now use its local IP and get to the transport layer. We're starting to unpackage. Okay, what ports protocols am I working with here? Where do I need to send this? How do I send this? Okay, it's been sent. We need to establish a session here. So we identified earlier in an example that there could be a session created to access that file potentially. And then from a file perspective, it's just waiting here. kind of always has a session because it lives on the server. So that makes more sense with the person example, but you can see here that the file has its own perspective on what is going on in this process because it's just waiting for this request right now. So then we go to the presentation layer. We're taking Alice's request, the information she wanted, and we're getting it ready for the application layer, which is actually just grabbing the file so that you can download it. So remember we had mentioned they have APIs on here, and we mentioned that the presentation layer, we're taking a lot of the data that we need for that, and here is the API where the session is, here's where the information gets translated or prepared for either for use or for transport, depending on which direction we're going here. So API lives here, but the data we need goes into this presentation layer, or that's where it's prepared at least. So okay, I need to pause. We're at the end, in fact, 2 minutes over our scheduled time. That's pretty common with these study groups if you've been around, so please forgive me for going over on time. You are welcome to hang out. We'll finish a couple more practice questions and then close out early, or not early, we'll close out a little bit late. But if you need to hop off right now, just thank you for being here. I really appreciate your time and looking forward to engaging with you in the community. So if you need to hop off, go ahead. Thanks for being here. Before we go back to practice questions, does anyone have a question on this or want me to walk through another scenario maybe?
Sorry, when you said that it broke up into segments.
Yeah.
Or yeah, so I imagine each segment kind of goes through the same journey.
Exactly. That's exactly right. So we have a lot of different segments. I'm just going to make up numbers here. Let's just make up numbers together, and I'll put them in. Well, here I got text boxes. Let's use text boxes. Please understand I'm using completely made up numbers just as illustrations here. Let's say I want to send a piece of data, and that piece of data, excuse me, has 1,000 segments. We had to divide it into 1,000 different segments to capture all of this data. Well, 1,000 segments might not fit in a frame. We might not have enough room for that entire bit of data on there. So we start to bring in sequence numbers. Sequence numbers help us to put these segments back together. They also help us to put together the packets as well. So we have segments, and segments live inside of packets. Packets are at the IP layer. So we have a packet, and it contains a collection of our segments, and segments have sequence numbers. So we get a bunch of packets coming in. We take them all apart, and we start looking at the sequence numbers so we can line up all the segments the way that they were meant to be. And then the last piece of that is frames, which just takes it down to that physical layer of where that lives. So we might have 1,000 segments, but let's just pretend we might only have 100 packets or something along those lines. So does that kind of help clarify things a little bit, Adam?
Yeah, and so does the frame, is there any frame that holds 100 packets, or is there 100 frames?
That is a good question. I'm not confident on a specific answer to that. I think that frames do only contain one packet, but they encapsulate a lot of other data within that. But I don't think they have multiple data packets. Does anyone have confirmation or refutation on that?
Could you repeat the question?
Yeah, I'm wondering if, so we have, let's just take this scenario that we have 100 packets of data that we want to transmit. Can a frame hold more than one packet, or is it one-to-one frame to packet?
So the frames, multiple frames constitute a packet. So when a packet is sent, the packet could have 100 frames, right? They could form one packet, and that packet is sent. Again, it differs from TCP and UDP. So take an example of a TCP. You have a TCP packet session that is one client trying to talk to a web server. So you load google.com. So that google.com page boils down to frames, say thousands of frames. And these frames go to the server. when they go to the server, there is a session, TCP session that is built. That TCP session sends this so many number of packets, and the connection is terminated after, say, few seconds. Now you go to google.com again on the page and you search for something. So what happens is a new TCP session is, if it is not already disconnected, a new session is created to the web server and more packets are sent. So how it's sent, it goes to, breaks it into frames, and the frames is sent as part of a packets, right? 100 packets. So how many packets depends on the page you are loading. If you are loading a PDF file, it will take more packets. So how many packets can be sent on a wire? The number of packets that's sent on a wire is whether it's the type of the medium. If it is Ethernet, you have a very large gigabit link. So number of packets may be more. But if you are on a dial-up, nobody has dial-up these days. But as an example, if you have a dial-up, you cannot send bunch load of packets. So what happens is the packet breaks down because you don't have that big pipe. So 100 packets are sent, then next 100 packets are sent, and then the next 100, depending on the bandwidth. So that is how, depending on the pipe that you have, the packets are broken down and then they are sent.
Okay, that's a great explanation, Venkat. I appreciate that.
Sure.
April, I also jotted down, just for my own understanding, I need to do a little bit more research, and I would like to have some, like, I hate making up numbers to this extent, but to actually understand some of the data limits and frames and segments and packets so that we can have a little bit more of a concrete discussion on that. But great question and great explanation, Venkat.
So I have a real quick, when the packet travels down, it's encapsulating, and then when it goes up, it's decapsulating, right? But
yeah,
but you mentioned about hops. I thought it only did hops when it was on the network. Are you just kind of using that word regular, like just using it? Because I just want to make sure the packet hops to different networks and they go different routes. But if you have TCP, it'll all be sequential, and that's the reason for the sequencing. But so, is it hopping during that encapsulation?
Can I take that, Josh?
Yeah, please do, Venkat. Yeah, so absolutely.
In a hop, from a network sense, a hop is where your packet travels. So when a packet travels, it goes from point A to point B. So when it travels from point A to point B, there could be many routers in your network.
Right.
So each of these router is called a hop. What is a hop? So a hop in a network means when I go from point A to point B, I have one router to cross, and that is one hop. If I have two routers, that is two hops. Okay. Why is hop important? If there is no, why is the number of hops is important? The number of hops is important because, say you have a network and it has the router, right? The routing protocol in a router tells you how many hops to travel before you can reach a certain server that you're trying to reach. So what happens if you don't have a limit on the hops? Nowadays, you have 255 and more hops based on the different routing protocol. But if you have a old, like a RIP or routing information protocol, yeah, I think it was the older version was 16 hops. So after 16 hops, the packet has to die down. Why do you need the packet to die? Say you're sending a packet to Google and Google server is not available, or for temporarily it's being shut down. So what happens is the packet keeps going on in the wild, in the network. So it's looking for that server, continuously going on. Say there is a networking error and the router is misconfigured. the packet is on the network. So what happens is so many packets on your network without dying. You're creating a broadcast in the whole internet. So why do you need a hop count? A hop count is used to tell your network that you will reach this router after say 16 hops. If you don't find a destination after 16 hops, drop the packet.
It would time to live.
Sorry?
It would be the time to live piece
Yes.
where it drops it. Got it.
Yeah. I can explain it if you.
Thank you.
Well done. I'm not sure why my request here for this is working. This is usually the way we would illustrate this.
Yeah. So what happens is sometimes, so this traceroute uses ICMP, and ping usually is blocked across certain routers. So that's why you might not see that.
Yeah, that's true. Normally, if you execute this command, you can try this on your own workstation. This is trace route.
Yes.
Essentially, what I'm asking this to do is I want to navigate to 8.8.8.8. This is the IP address for Google's DNS server. And it's going out one hop. So it's going from my workstation or my network interface card to the next hop and how it would get there. In this case, it would be my little office router. Once it takes that hop, it comes back and reports in. That's the requests are timing out here. I'll exit out of this. But then it'll just go out to the next hop after that. So it would hit my router and my office, and then it would go to my router and my home. And then it would go to my ISP and bounce around their routers until it finally got here. So you were actually tracing the physical path between the physical workstations, or between the IP addresses, at least, of this, how the traffic would flow. Great explanation of that, Venkat. I wish this would have worked. That would have been nice. Let's see.
Thank you both. I appreciate it.
Absolutely. Venkat, I'm glad to have you here. I've mentioned before that people typically have weaknesses in some domains and strengths in some domains.
Yeah.
I come from more of a technical security and vulnerability and have to work at these layers more often. Venkat, I'm assuming you maybe get to work with software or APIs in your work?
Yeah, more on the software and networking. Those are my strong suits.
So you're here to fill in on my weaknesses. Thank you. Excellent. Okay, who else has a question on this? We're going to do one or two more practice questions to wrap up here.
So I guess, sorry, just to finish my thought from before. Yeah. So the packets, like there's nothing really binding them together. They basically all just kind of get sent out, and it's just the sequence number that the destination has to kind of collect them all.
Yeah, there might be packets that get there out of order. So exactly right. Those sequence numbers help to line those packets and then similarly the segments up. Yeah, exactly.
But there's nothing really to bind them together as they go through.
No, packets may even have different routes that they would end up taking if the connection is interrupted and we're using connection oriented. It's possible, especially even in load balancing. Typically, that's not the case because our communication happens in such a brief amount of time. It's so fast, but it is possible. Our packets have all the information they need to get there. And every time a packet hits a router or an endpoint or a hop, then it goes through this process. So if for whatever reason, the MAC address of this router changes for the MAC address it knows is the next hop, then the route would be different. The packets would still have the same source and destination IP address, but they would be now passed between different devices, different routers, potentially in load balancing, but they would all end up at the same place. It would be the equivalent if you have Google Maps and it has the recommended routes both showing up as kind of similar time. Yeah. Okay. Great job on that. Great questions. Venkat, again, thank you. And Saravanan for your guys' help. I really appreciate that a lot. All right. We'll look at this one just briefly. We won't do the actual question part, but who can tell me offhand what kind of an address is this?
Loopback?
Loopback address. Exactly right. This is your host. It's used for testing a lot, or as a place to send traffic to, and it shouldn't leave your network. This, an RFC 1918. This is request for. What is the C in that? Does anyone request for comment? Request for comment. Thank you. Request for comment. This is our classes of IP addresses. This is the request for comments. 1918 is what actually dictates those. So we have class A, B, C. This is kind of how the internet decides what is public versus what is private and what network class is used for what purposes. So not quite relevant here, but we have the loopback address and a PIPA where I had this is used as a fallback address, and I had the acronym jotted down somewhere. I don't remember what PIPA stands for. I'm just looking that up real quick because I don't quite remember. But this is, you'll see it as a 169.254, I think, address, or maybe 116, but 254, yeah. So this is automatic private IP addressing. So if you go look at your network settings ever, and you notice you have an PIPA address, something beginning in 169.254, you know there's some issue with your network configuration. It's not getting an IP address, so it's self-assigning. It's automatically assigning itself its own private IP address.
Yeah,
it has a specific range for that. Yeah, April.
I thought that was a database. That 169 was a database. That
no.
had a PIPA. I mean, I know if it's, maybe I'm thinking differently, but I know if it assigns itself it again, it just, there seems to be a problem. Well, you know what? Let me just back out. Let me figure that out. I'll research it.
Yeah, let me know if you have a question coming out of that, April. Yeah.
Okay. Thanks.
Yeah. Excellent. Okay. Yep, we discussed loopback address. Okay, this will probably be your last practice question here. Yeah, this will be our last practice question for now. Okay, so does anyone know well, let's look through this here. What kind of denial of service attack sends fragmented TCP packets? What layer of the OSI model are we talking about if there's TCP packets involved?
Transport layer?
Yeah. Yep. Or yes, correct. Yeah, transport layer. Good job, April. Okay. The correct answer here is teardrop.
Yeah.
Let's go take a look at what a teardrop actually is. Because you can see we're taking advantage of fragmented TCP packets. Well, this might help Adam with our conversation earlier on sequencing, because this is exactly what a hacker is going to take advantage of in a teardrop attack. They're going to take advantage of the sequence numbers, and they're going to take advantage of, imagine if you had a 1 through 10 list that you wanted to list out in order. Well, imagine if you had 2 number 2s. That would create a little bit of confusion if you're trying to line them up in order and like, well, I have 2 of these. I don't really know which one to take, which is the correct one. It's the equivalent of here, we send conflicting data with overlapping sequence numbers so that when they're trying to reassemble this information, it just doesn't make sense. There's conflicting data. It starts to crash things. So a teardrop attack can create a denial of service because we're tying up a lot of processing power and they don't know what to do with the information that we're giving them. A lot of times they will just reset the connection and start over, again, creating more traffic and denying us the service that we want. So that confidentiality, integrity, and availability. We haven't talked much about availability the last couple of weeks, but this is an area where availability is what's being targeted. So that's a teardrop attack. Basically just, okay, I'm going to overlap the data. I'm going to make a mess out of it. I'm going to use fragments in that way so that when we're trying to reconstruct it, it just does not work and we have to start from scratch. And we'll just take advantage of that.
So I guess in that example, you could just send one packet and force your target to have to send back thousands of packets because it got confused.
Absolutely. There's scenarios where we can do that, where we can send something to them that makes them think, okay, I need to send a lot of data back. Yeah, absolutely. There's attacks that scale like that really well for us. Yeah. Who can tell me what a Christmas tree attack is?
Oh, I think I got it. I know it has 2 flags or has a finish. Like it's asking to clear the way, basically. So TCP is it has a few flags, and that's why they say Christmas tree, like one urgent and one is
oh, you're so close.
finish.
What's the attack that April is referring to, where we're just sending reset flags?
Right, reset, exactly.
What's the name of that attack? Someone have that offhand? It's not Christmas tree. You're on the right track though, April, talking about flags.
Oh.
I think it's just called maybe a TCP reset attack. If any, there might be, they have specific names for these, like teardrop.
Okay.
Right, but yeah, that's a reset attack where you send a reset the connection flag to on an ICP or in a packet. So the recipient thinks, okay, we need to reset the connection. Let's start this game over. Well, you can just send that reset connection over and over. And now you're opening up these connection points. So think of it like I'm trying to knock on a door, asking to be let in. I'm trying to create a connection. So they open the door to let me in, but I've left. I've ding dong ditched them and I've gone to another door, knocked on that. And they open their door. Soon all the doors in their house are going to be open and occupied. So real guests wouldn't actually be able to get in.
Right.
So that's kind of the denial of service point of that attack you're mentioning. Is there a more specific name for it? Does anyone know offhand? I kind of forget the name.
That's a SYN flood attack, right?
SYN flood. That's right. Okay, sending SYN packets, not resets. That's a different name there. But yeah, great. SYN packets. We're manipulating the flags. A Christmas tree does that exact same thing. It manipulates the flags, but what it does is it sets all of the flags. So it sets reset, finish, it sets push. I think there's 8 total flags maybe, or 7, but it'll set them all. And that's, again, just to create confusion. And next endpoint gets this and looks at it. What am I supposed to do with this? I don't know what you're trying to communicate. You selected everything. What do we do with this? And so it creates a lot of confusion. That's the Christmas tree attack. We're lighting up the flags like a Christmas tree, basically.
Mm-hmm. The flags are on the frames?
Yes, great question. Okay. Great question. Oh, maybe
on a segment.
Let's look. Yeah. Let's look, because how many are there? 1, 2, 3, 4, 5. Oh, 6 of them. Okay. So let's see. Where are these set?
So when they're a segment, they're in a network.
Yep. So they're going to be there. Exactly. So segments will have these different flags. They don't necessarily need to have them set, but we've talked about the 3-way handshake. The first one will be a synchronization. So we're trying to start a session. We're knocking and opening that door. Sravanan mentioned that we can manipulate this for a SYN flood attack. We flood them with SYN requests. We just go around knocking on all their doors, waiting for them to open them. In the actual 3-way handshake, we send a SYN packet. We receive an acknowledgement packet that also has the SYN flag set for us. It's essentially the server that we're trying to establish a connection with saying, okay, I'm acknowledging you want to start a session. Here's my own SYN synchronization flag. So this is packet 1 is just just SYN. Packet 2 is SYNAC. And then your client, once your session is actually established, will respond again with the FIN after they're all done. Yeah, SYN, SYNAC. Yeah. And then there's, well, we're not going to go into all the different attacks that can go on flags. We're well over time here. So we're going to go ahead and wrap up. Let me stop presenting. So if you do have additional questions or things that weren't covered in the session, we are going to move on to domain 5 next week, but please send me a message or post a question in the Skool community because we'd love to get accurate answers for you. Venkat and Sravanan, I want to thank you guys especially for you guys' contributions and helping me out. I really do appreciate that. I'll always be honest, if I don't know the answer to something, I'm really grateful to have guys on the call who are willing to step up and help us out. So thank you.
Thank you.
Yeah. Okay. Well done, everyone. Keep up your hard
Thanks
studies.
so much.
Looking forward to seeing you all on Thursday if you're able to make it. Yeah, take care, Annette. Thank you, April.
All right.
Thank you.
Absolutely,
Thank
Rebecca.
For Thursday, did you say you're beginning domain 5 or it's next week?
Great question. So next week, this same time, we'll begin working through domain 5.
Okay.
Thursday, depending on where you're at in the world, I guess, the Thursday session 2 days from now, or a day and a half, will be basically a repeat of this information. We'll do the same practice questions, although we didn't get to all the practice questions today. So yeah, it'll be mostly repeat on Thursday, and then we'll move to domain 5 next week.
All right. Thank you.
Thank you.
Rebecca, it was lovely having you here. Thank you for joining us.
Same here. Thank you.
Thank
Have
you,
a good
April.
one, everybody.
Thanks,
You too.
Thank you.
Bye.
Thank you.
Great to have you here. Marcia, it was lovely meeting you. MD,
Nice
thank you for
meeting you.
being.
Thank you.
Looking forward to getting to know you.
Thank you. Bye.
Bye.
Quick
Annette.
question, Josh. Did Paul pass his exam?
He did, yes.
He did.
Yeah,
Awesome.
he came and joined. I don't know if you caught that, but he joined us
No.
for a while to answer some questions, and he passed. Yeah.
I was dealing with the VPN issue and my.
Yeah.
I've been trying to figure out that VPN issue since Sunday.
Oh man. Well, use our OSI model to troubleshoot if you need.
Yeah, it looks like his site there, because we have government computers and we have hardening.
Oh
It
yeah.
looks like his site, like his computer, it's blocking it.
Oh.
I even tried, like, having him change the DNS, the IP address straight to the server that has the download. That way he can just download it from there.
Nice.
But it's not. It's blocking it. Like something's. It keeps on filling the connection. Finally
Interesting.
and then finally got it to bypass that. And then he tried downloading his. They told him, okay, well, you can't download this version because you need to upload your. You need to update your OS on your Mac.
Oh.
And then it finally got it to update. It took 2 hours for him to update his OS. And then finally, I just told him again that it's blocked.
Yeah. Oh, geez. It's always something, isn't it?
Yeah, it is. But thank you so much for your help. I was wondering that because he said something about Pun. I was like, hey, did he pass already?
He did. Oh man, isn't that just so awesome? I mean,
It
you
is.
see him showing up and working hard. It's just.
He's working hard. Yeah, he deserves it. Sandra takes hers pretty soon then?
Yes, she takes it. I think she said in 1 week. I can't remember if it was a week to the day, but yeah, coming up very soon.
Awesome. Okay, I'm hoping she's good. She'll pass too.
Oh, I think so. You've been studying hard. Yeah. You're up next.
No, thank you, Josh. You have a great evening. Okay, I won't take too much of your time.
Good job, Annette. Thank you.
Thank you.